Hi everyone, we are Group Stay Hungry. Today our project topic is dynamic portfolio construction with machine learning methods in Nasdaq 100 components. Our main content consists introduction, stock selection, portfolio allocation, backtesting, performance evaluation, and the final conclusion. First, let me introduce our core investment idea and data to you. In today's world, stock recommendation is vital to investment, and value investing has been widely adopted. In 1998, the concept of intrinsic value was proposed, which reflects companies' market size, financial strength, and other factors. Many fundamental financial ratios were developed based on this concept and used to predict the stock return for their good explanatory power. Thus, based on this concept, in this project, we develop stock selection models that can automatically generate a trading strategy for the next quarter with a portfolio of 10 traded stocks. In detail, first, we use rolling windows to divide data. Then, on the rolling basis, use machine learning algorithms to select stocks dynamically. After the selection, we test asset allocation methodologies and compare our portfolio results with the Nasdaq 100 index. Finally, after we have the fixed 10 stocks in September, we obtain the performance in October. Now we look at our data. We use all historical Nasdaq 100 component stocks, which is 102. And the data set we use consists of data over the period of almost 11 years. And the adjusted close price goes on a daily basis. For the quarterly stock return, we use the natural logarithm wise. And as we mentioned before, we use fundamental financial ratios to reflect a company's intrinsic value, such as current ratio, return on asset. But it is a limitation that we can only obtain the quarterly basis data according to the company's report releasing time. Now hand over to Mengjia to show you the stock selection.
Let me introduce stock selection. Rolling windows were employed to divide data for training, testing, and trading sets. The training window is 16 quarters, followed by a 1-year testing window, and we trade according to the test results. From 2011 to 2021, we have 22 rolling windows by shifting 1 quarter for a previous window. In each window, we use 5 machine learning algorithms to assign coefficients to selected vectors dynamically, including linear regression, forward and backward stepwise regression under AIC, regularized linear OLS estimator ridge regression, tree-based nonlinear model random forest, and generalized boosted regression model. Our implementation can be summarized as following steps. First, for each window, train and test the model to get the MSE for each of the 5 models, and then choose the model that has the lowest MSE in that certain period. Step 3 is predict return of the trade quarter using last quarter's financial ratios and coefficients returned from the selected models. Use the predicted return to pick top 10 stocks. Then we get a final table of all selected stocks with its ticker, predicted returns for each trade quarter, and the corresponding trading periods to conduct portfolio allocation. Next, Xingkun will introduce portfolio allocation.
Thank you, Mengjia. After stock selection, we consider the portfolio allocation. Portfolio allocation is crucial to an investment strategy because it balances risk and return by modeling individual assets weights. In our portfolio, we use mean variance and minimum variance to decide the weights of each stock, and then we use equal-weighted portfolio as our benchmark. We first use mean variance optimization to allocate the stocks we have picked. The target is to maximize the Sharpe ratio of the portfolio. We use predicted return of the next quarter as expected return, and we use 1-year historical daily return to calculate the covariance matrix. There are some constraints. We assume that we fully invest our capital, so the sum of weights equals to 1. We consider long and short the stocks, and in order to have more diversity and to avoid the weight being concentrated on one stock, we've set the upper bound to be 50% and lower bound to be minus 50%. Then we use the minimum variance optimization to allocate the stock we have picked. The target is to minimize the volatility of the portfolio, and the constraints are the same as the mean variance method. Last, we set the weight for each stock as 10% for the equal-weighted portfolio. For each trading date, we calculate weights for mean variance portfolio, minimum variance portfolio, and equal-weighted portfolio. This table shows an example of weights for trading date July 1st in 2021. Now, let's welcome Yuanjia to introduce our backtesting.
Thank you, Xinhun. In backtesting part, we compare the performance of different allocated portfolios and the benchmark portfolio Nasdaq 100 index. Here is the performance, which are quarterly returns of these portfolios. We can see that the shapes of the quarterly returns are similar, while in January 2020 and July 2020, equally weighted portfolio depicts a more obvious better return. To see the return in a long run, we calculate the cumulative return in 5 years. It also displays the result that equally weighted portfolio outperforms others. Assume our initial value invested in the portfolio is $1 million. In 5 years' time, the value of different portfolios are backtested and plotted in the same graph. We can make the conclusion that minimum variance allocated portfolio and mean variance allocated portfolio will result in a slightly higher value than benchmark, while equally weighted portfolio will result in a higher value, especially in 2020 forward. To compare the performance in figures, we use annualized return, standard deviation, and Sharpe ratio. Sharpe ratio of mean variance portfolio even does not beat benchmark NDX, while equally weighted portfolio still outperforms others. So, we choose equally weighted methods for portfolio allocation in this project. Now, let's welcome Jianyi.
Thanks, Yuanjia. Next, I'll be talking about the performance evaluation from August to October in 2021. Based on the financial ratios for Q1, we performed the stock selection and ranked the top 10 stocks with the highest return as below. In August, the portfolio weight is equally distributed. Our portfolio achieved a 29.25% of annualized return with the Sharpe ratio of 1.61. Observing the bad performance of Zoom in August, the holding was removed from the portfolio, and the capital was evenly distributed to other stocks in the portfolio. In September, our portfolio achieved a 4% of annualized return, and the Sharpe ratio was 0.23. In 2021 August, a new list of stocks was recommended by the selected regression model, with the latest financial ratios available for 2021 Q2. Based on experience in August and September, Zoom was again removed from the portfolio and the capital was equally invested on the other recommended stocks. The annualized return was 112%, with the Sharpe ratio of 5.1. The annualized return for the benchmark Nasdaq 100 was 94.80 in October. Thus, our trading strategy outperformed the index by 80%. Next, conclusion. In the project, we constructed a dynamic stock selection method that can find the best model among 5 different machine learning algorithms, which can best predict the forward returns with 50 financial ratios. Next, we recommend the top 10 stocks in Nasdaq 100 that are expected to have the highest return in the next trade cycle. Next, based on the backtesting result, equally weighted method together with the no leverage rule was the best portfolio allocation method that can provide the risk managed and diversified portfolio which can yield the highest Sharpe ratio. Compared to the benchmark, our trading strategy outperformed the Nasdaq 100 index in annualized return, not only in the past but also in October 2021. Further improvements that can be done on this project include automate the portfolio adjustment within each quarter. For example, automatically remove the bad performing stock in September based on the performance in August. Next is apply the stock selection process on a wider range of stocks. For example, the components of S&P 500. That's all for our presentation. Thanks for listening.